Warm greetings. Equation of state. There are two postulates. First one is state of a thermodynamic system can always be defined using primitive variables. Primitive variables including mass, volume, temperature, pressure, etc. Second state postulation, that is number of independent intensive properties required to define the state of a system is the number of two-way work modes plus one. So here intensive property that are independent of the mass, like temperature, pressure, density. Here density is also intensive property because density is not dependent on the mass, and it can be explained as if you take 1 gram of any substance or 100 gram of any substance, the density of that material will be same, so it is not dependent on the amount of the material. So the equation of state for an ideal gas, that is PV equals to mRT. Here R is gas constant and its unit is joule per kg Kelvin, and it is also equal to 8.314 divided by molecular weight, and this 8.314 is the value for universal gas constant, and universal gas constant unit is joule per mole Kelvin. So enthalpy H equals to U plus PV, and if we take specific, so specific enthalpy denoted by small h, small letter like small h equals to small u plus small p and small v, that all specific means per gram. So if we put RT in place of PV, so it will be enthalpy, specific enthalpy will be equal to small h equals to U plus RT, and if we differentiate it with respect to temperature, dH by dt equals to U du by dt plus R. So dH by dt is specific heat capacity at constant pressure, and du by dt is specific heat capacity at constant volume. So in this way, Cp equals to Cv plus R, or we can derive Cp minus Cv equals to R. Also, the ratio between Cp and Cv, that is Cp by Cv, is equals to gamma. So from this derivation we can say that enthalpy is a function of temperature only. Thank you.